Hey guys, welcome back to GeekJ, where we make tech tutorials and gaming simpler and better. Running local AI models should not require a computer science degree in my opinion. But if you've ever tried using llama.cpp, the fastest, most optimized engine for running large language models locally, you know exactly what I'm talking about. First, you need to download llama.cpp from GitHub and make sure you grab the right version for your hardware. I'm on AMD, so I need the HIP build, which basically allows you to use the ROCm kind of back end for things. NVIDIA users need the CUDA version, and Intel is probably better off running OpenCL. And are you already confused? Yeah, it gets worse. So links for everything we use today will be in the description below. So let's go on ahead and download llama.cpp from their GitHub page. As always, we will go over here that says plus 4,940 releases. And they do update pretty often, so yeah, keep an eye on their updates. I'm gonna go into show all 22 assets, and it's near the bottom, as you can see over here, llama B and the number of the version, and then we see the binwin HIP Radeon X64, and this is the one we need to download. I'm gonna click on it. As mentioned before, make sure you download the correct version for your setup. So now that we have llama.cpp downloaded, I'm going to extract it, and I usually extract it directly into my C drive and in its own directory. So for simplicity's sake, we're going to do exactly the same thing. And as you can see, this is the newest version on the right side. So if I double click on this, we have the 7Z window open up, and you can see there's a bunch of files in here. And if we go in my previous HIP llama cpp, we can see like we have the same exact stuff, and nothing is saved in here, so feel free to just shift delete everything in here when you're updating, and then just drag and drop all the files from the 7z file into the same directory. And that's how I usually upgrade the installation of llama.cpp on my setup. I'm gonna exit out of 7Z over here, and this is basically my way of keeping things extremely simple. And yeah, we just need a model to actually run now. So the best and easiest way to do this is to just head over to the Hugging Face website. And this might seem a little overwhelming, but it's quite simple if you get the hang of it. I just click on models over here, and I usually filter for GUI models, which are compatible with llama.cpp. And I'm just gonna go with llama.cpp over here and GUI, and that's basically the filtering I do. So let's find a model that is fairly reasonable in size, so that means it's not going to be with too many billions of parameters. We could go with something that is not just trending, but I usually like to go with let's say most downloads. Let's try Nemotron, which is something by NVIDIA, and I think it has been recently updated, and it's the 8 billion parameter one. We could try this one just for fun. So let's try the let's say Q4 that can even fit in a 6 GB graphics card, for example, because we do want everything to fit in the VRAM because it is a lot faster than our system RAM. Q stands for quantization, and it basically kind of shrinks the model, not too much. If you go like Q2, it kind of messes up a lot of its, let's say, tables that it uses to organize where everything is and make it more accessible to normal hardware. But yeah, let's just go with the Q4 over here, KM. And pretty soon we're going to see a lot of this, mumbo jumbo. But don't worry about it. Just click on this use model drop down over here, and we're going to go with llama.cpp. And as you can see over here, it is giving us a command to basically download and run the model. So I do not like this copy button over here because it's gonna grab this little comment over here as well. So I just select everything and either Control C or just right click and copy this command. So to download and run this model, we fire up the terminal. I know, dramatic music and stuff for a scary movie or something. And we need to navigate to our llama.cpp folder and run this specific command. So I've run the terminal and it's installed by default on Windows 11. If you're on previous versions of Windows, I think Windows 10, you can also install the terminal through the Microsoft Store. If you don't want to though, you can use PowerShell. So yeah, let me first of all go into our C drive, and then we need to navigate into the llama.cpp folder. It was llama.cpp _HIP, I think. So here we are. If we run the directory command or dir command over here, you're going to see a list of all the files that are present in that folder. So just running a command, that's simple enough, right? But wait, what if you want to save your models somewhere else? Because initially the command would have to be something that looks like this, right? And it's going to save it in the predefined location that only llama.cpp knows or something. You don't know that, right? But let's say I already have a folder where I wanted to save my models. So what do? So, time to dig through documentation, and then the command, once you find it, will change to something like this. So we need to set the environment of, where our models are going to be downloaded and loaded from, and the rest of the command stays the same. So that's fine and dandy. But then something very usual, what if you want to change the host address, right? And add more flags like custom context size, or even GPU layers, or if you want parallelism, which is something that is directly and immediately supported in llama.cpp. You guessed it, it's more flags. So you have to go digging through documentation and see how you can change this command each and every time you want to run the model. So for example, if we wanted to do this, I would press enter and it will start downloading this model. And once it's done downloading, we will probably be able to use it. So let's wait for that. Okay, so as you can see, the model is loaded over here, and you can see that we have some VRAM usage. So the model is loaded into our RAM. And if I click on this little hyperlink that it has provided us, it's going to open up its own WebUI. Basically, llama.cpp has bundled with it, right? So we can ask it a question, and let's keep our task manager active over here, so we can see that it is already using some of my GPU because I'm recording on OBS. Let's ask this model a simple question like, write me a short story. Write me a short story. And it's going to start doing stuff. As you can see, the compute unit is, doing something over here. It is reasoning, so it's still thinking on what to do, and it's writing our story. You can see that context is practically being used. Okay, and as you can see, it's using about 72 tokens per second. It is working, but as we talked about earlier, what if we want to add more GPU layers, or we want to increase the context and stuff? We need to know our way around the commands. Then if you think about it, what about deleting models? So that means, I hope you remember your PowerShell commands, right? Let's see, if I exit out of this terminal window, you can see that the VRAM usage went down. So we're not using this model anymore. It's unloaded. And basically, if we want to delete it, we would have to open up a terminal again. If you're familiar with PowerShell commands, you would have to go with remove -item. So I have to go over here and grab this, I suppose, for the name. Then I'm gonna go over here and replace this one with this, and then do another star over here. And then I'm gonna just close the quotes and do recurse and force, and hopefully it's gonna delete that model. And yes, it did. So this is how you'd have to move around if you're using llama.cpp. And yes, I know some of you are already typing in the comments kind of angrily, why don't you just use Ollama, or LM Studio does exactly this? Well, let me be the bearer of bad news. Here's the thing, they don't, not quite. So Ollama is like Docker for models. It has a great API and it's pretty easy to set up, but it only recently got basic GUI, and tweaking sampling parameters is kind of painful. And honestly, they seem to be pivoting toward cloud hosted models that they charge for. So I'm not a fan of that direction, and I'm not really using Ollama anymore. LM Studio also has its benefits, has a really sleek interface and a built-in Hugging Face browser. It's super convenient, but first of all, it's closed source. So for me, it's another big red flag. And it's also heavier on resources, and it's pretty hard to integrate into scripts or any kind of automation. And also, it kind of struggles with parallelization. And basically, if you think about it, llama.cpp gives you the highest performance. You can basically run it on a potato, and it is literally the foundation that Ollama and LM Studio and everything, pretty much everything else that is running a local LLMs is built on. And the problem, it used to be the steep learning curve, and it has complex flags, and there is basically no model manager, or at least that used to be the problem. And if you're thinking, but I use Open WebUI, stick around, LlamaForge plays nice with that too. Okay, let's get rid of the terminal, and you see this little llama looking icon on my tray icon is over here. I will right click, start the service, right click again, and I'm gonna open this. And this is LlamaForge, the GUI or GUI for llama.cpp that I built because this problem wasn't sitting right with me, boys. So I think that AI and technology in general should be accessible to everyone, not just terminal wizards or, super tech savvy people. So let me give you the tour of how this works. So up top over here, you set your model's folder path, and you can browse to select it. And then you can also hit the scan folder button over here, and all your existing models will appear in this drop-down over here. So I can just browse for it, and once you browse for it, once it remembers everything, so you can just click on scan folder, and all of my existing models are going to be located over here, as you can see. So no command line required, right? That's pretty cool. What if you want a new model? We can go back to Hugging Face and grab that link as it was. We don't need to change anything else over there. So let me demonstrate. This was the command, right? Let's download the exact same model. So I'm gonna just paste it in here, right? I'm not adding anything else. And the only other thing you need to worry about is to point it to the right path to where llama server.exe is located. And for me, because I like to keep things simple, it was the C drive and then its own folder. And as you can see, it's already listed over here, llama.cpp _hip. And then I pointed to basically the exe that it is asking for. But yeah, if we clicked on start over here, it would just automatically download our model to the correct location, right? And it would load the model automatically, and that's it. But here is where it gets really, really powerful, at least in my opinion. So this is pretty important, the server path, because let's say I want to try the OpenCL version of this, I could just point it to that. So if I go to my C drive, you can see here I have the OpenCL. So it's gonna basically run on Vulkan. I can just run this one, as you can see over here, and now it will run on basically Vulkan or OpenCL. So let me go back to HIP or ROCm, and this is huge because you can switch between different builds. HIP for AMD, CUDA for NVIDIA, OpenCL for Intel, or Vulkan for any of the above, I guess. And if you have multiple GPUs from different vendors, it's no problem. Like, you can select which one of these you want to use, and it will automatically load the correct one. Also, every single parameter has a tooltip explaining what it does. Context size, as you can see over here, GPU layers, threads. You can just hover over the question mark and you'll know exactly what you're setting. So as I adjust these settings, what's the command preview? So let me minimize these, and let's say I want to have 999 GPU layers, which means it's going to load the model only on the GPU exclusively, as long as it fits in the memory, basically. Let's say I want to go with 16,000 memory contacts. The port, I'm going to leave it as is, and I want to run it not only locally, but I want to expose this on my network. So I'm going to put in my local IP for this PC that this is going to be running. And if you were paying attention, the command preview basically updates in real time, and you can see exactly what command will be executed. And listen to this, it's my favorite part. If there's a flag missing because, you know, llama.cpp adds new features before I update LlamaForge, or you just want to quickly tweak something, you can just click the edit button over here, modify the command directly, and just run it. That's it. It's full flexibility. Like, if I just wanted to, I want to change, you know, this to 8192, done. That's it. Apply changes, and the command is changed. Obviously, we have all of the parameters that are available right now, like the batch size, we have the parallelism. So let's set this to 2, for example. I don't know, what else do we want to do? I'm gonna enable all of these options. And then let's say we want it to be a little bit more creative. So I'm gonna go with these settings over here. And yeah, this seems pretty much what I want. And I'm gonna click on Start Server. As you can see, we have the runtime status over here. It is downloading the model just like it was doing when we were on the terminal, but we never touched any command line. Everything is happening in this GUI. We can check which runtime it is using. We can view the server logs for debugging. We can immediately just click on the Open WebUI, and as you can see, this is the model over here that we are running, and we can directly ask it questions. So, hey there, tell me a joke. As you can see, we have been doing a lot of rigorous testing for this. And as you can see, it is using 76.6 tokens. And since LlamaForge runs a server, the possibilities are endless. Using Open WebUI, just add your LlamaForge server to your connections and you're done. Same model accessible from Open WebUI's interface. And I'm just gonna show you that right now. So as you can see over here, because it is in my connections, it automatically loaded the model we were using. And if you want some proof that this is running locally, I will have the task manager running over here on the side. And let's type in, tell me a 100-word joke. Wait for it to do its thing. And as you can see, it used our GPU, and it says over here that it used, this is kind of weird. So what happens if, we cannot really understand what it means over here, but we do want to see the stats of what it was using? We go back to LlamaForge, and as you can see over here, ooh, look at that. It was using 77 tokens per second, which is in line to what it was using in general before when we were running it standalone from its own WebUI server. Using OpenCode on a Linux machine, SSH in, fire up OpenCode, select your model from the list, boom. You're just chatting with your local model from a completely different machine. So let me show you how that looks. So as you can see, I have SSH to a machine that I was primarily using with the pterodactyl panel. Let's go ahead and run OpenCode. So in OpenCode, just type in models, and let's try and find our own model. And will you look at that? llama.cpp is over here, and it's running our own model. And as you can see, we can ask it, what does this contain? And I just added a bunch of random text in this Gemini.md file, and it is indeed working through the OpenCode, setup we have over here. So let's exit out of this. I'm gonna stop the server, and you'll see that immediately the usage is dropping. The VRAM is also going down. There is some VRAM in usage because, again, we're using OBS Studio. So all the numbers you see here for the RX 6800 XT will be a little bit better because right now we are using the GPU to record this video. So I don't know if we're going to have any type of hiccups on the actual video because it is actually using a lot of GPU horsepower to run these models locally. So yeah, hopefully the video is going to be fine. So yeah, once you're done, you can just stop service and then exit out of LlamaForge. And basically, you can chat with your local AI from anywhere at any time. So yeah, if you want to download and use LlamaForge, head over to my GitHub. The link is, as we mentioned before, in the description, where, below. And you can grab it completely for free. And as you can see over here, we have some releases. This is the first beta we have released. You just need this standalone exe file and you run it and it does everything locally. And it's going to be pretty nice to have people testing it out. And if you have any issues, you can open up issues over here. And again, it's open source completely for free. Obviously, if you want to support my work, there's a PayPal link over here, a donate button. And I'm still working on getting GitHub sponsors set up, but Japan is being kind of weird about it. And yeah, we'll get there, but yeah, just be patient. If anyone feels like donating, there's the button. You don't have to. I'm just mentioning it because it's really going to support my work and everything we do here in GeekJ, basically. Obviously, if you're curious about the other projects on my profile over here, as you can see, we have LlamaForge, we talked about right now, and then we have OmniLink and Context Keep. Check out the profile and stay tuned to the channel. And probably I'm gonna be making more videos about these projects as well. If this helped you get your local AI setup running smoothly, don't forget to smash that like button, subscribe, click on that join button if you want to become a member, and you get a lot of benefits like the legends I'm gonna mention pretty soon. And yeah, click on that bell to never miss another video ever again. Feel free to use the super thanks or whatever if you feel like supporting what we're doing here with GeekJ. That's it for this video. Drop your results in the comments. I read every single one of them. And yeah, I will see you in the next one. Bye-bye. Bye. Bye. And of course, a massive thank you to my channel architects, Paris STR and Kostas Dari. You guys are just legends.